Let's begin with something that should be completely stable. The empty space around you right now. You probably think of vacuum as nothing, just the absence of stuff. But in quantum field theory, empty space is actually seething with energy, held in a delicate balance that keeps reality functioning. What if I told you that we could be living in what physicists call a false vacuum, a cosmic house of cards that could collapse without warning? The false vacuum theory emerges from our understanding of the Higgs field, the invisible energy field that gives particles their mass. Think of it like this. Imagine you're a ball sitting in what you think is the bottom of a valley. You've been there for billions of years, completely stable, assuming you're in the lowest possible position. But what if you're actually sitting on a ledge halfway down a much deeper valley? What if there's a true bottom you haven't found yet? In quantum mechanics, particles can tunnel through barriers that should be impossible to cross. They can borrow energy from nowhere, slip through walls, and appear on the other side. If our vacuum is false, if we're sitting on that cosmic ledge, then eventually the Higgs field could tunnel through the energy barrier, keeping us stable. When that happens, reality as we know it ends. The collapse would start at a single point somewhere in the universe. Just one microscopic spot where the field drops to its true lowest state. From that point, a bubble of true vacuum would expand outward at the speed of light. Inside this bubble, the laws of physics would be completely different. Particles would have different masses. The forces that hold atoms together might vanish entirely. Chemistry would become impossible. Here's the truly horrifying part. Because this bubble expands at light speed, you would never see it coming. Light carries information, but if the destruction is traveling at the same speed as light, the information about the approaching doom would arrive at the exact same instant as the destruction itself. One moment, you'd be reading this, thinking about your day. The next moment, you simply wouldn't exist. Your atoms would fall apart before your brain could process what was happening. Some physicists calculate that if this event were to occur, it wouldn't just destroy life. It would erase the possibility that life could ever exist in the affected regions. The bubble would keep expanding forever, consuming galaxies, rewriting the cosmos into a form incapable of supporting any kind of organized matter. Could this happen tomorrow? The probability is small, but it's not zero. And the most unsettling aspect is that it might have already begun. Right now, somewhere in a galaxy, billions of light years away, reality might be unraveling. We won't know about it until the moment it reaches us, if it ever does. But let's assume our vacuum is stable. Let's move on to something that should definitely be safe. The matter you're made of. Your body consists of protons and neutrons that have remained stable for billions of years. These particles seem absolutely reliable. We build our entire understanding of chemistry and biology on their consistency. What could possibly go wrong with something so fundamental? This brings us to the strange matter hypothesis. Deep inside neutron stars, where matter is crushed to densities beyond anything we can imagine on Earth, regular protons and neutrons get squeezed so hard they might transform into something else entirely. Under these extreme conditions, the quarks that make up normal matter could change into strange quarks, creating what physicists call strange matter. The disturbing possibility is that strange matter might actually be more stable than the regular matter we're made of. If that's true, then every atom in your body, every particle in the Earth, represents a higher energy state, desperately wanting to transform into something more stable. Strange matter would be like a virus for regular matter, converting everything it touches. Picture a microscopic droplet of strange matter, smaller than an atom, drifting through space. When it hits Earth, it wouldn't stop at the surface. Its incredible density would carry it straight through the crust toward the core. On the way down, it would interact with regular atoms, instantly converting them to strange matter. Each conversion would make the droplet larger, giving it more surface area to convert additional atoms. This would create an exponential chain reaction. The strange matter would consume the Earth's core, then the mantle, then the crust, converting our entire planet into a dense ball of strange material about the size of a football stadium. The process would happen quickly, perhaps within hours. Everything that ever lived, every human achievement, every trace of biological history would be transformed into an inert sphere of exotic matter. The reason many scientists don't lose sleep over this scenario comes from what's called the cosmic ray argument. High-energy particles have been bombarding the moon for billions of years, with energies far greater than anything we can produce in our particle accelerators. If cosmic rays could create stable strangelets, the moon should have been converted long ago. Since the moon is still there, strange matter is probably either impossible to create or unstable and short-lived. But here's where it gets interesting. Cosmic ray collisions are random and chaotic. What about the controlled, precise conditions we create in our most advanced particle accelerators? When we smash heavy ions together at near light speed, we're recreating conditions that existed in the first moments after the Big Bang. We're deliberately creating environments where strange matter could potentially form. The safety reports from facilities like CERN conclude that the risk is negligible. Notice they don't say zero. In probability theory, if you repeat an experiment enough times, even negligible risks eventually become realities. And if strange matter theory is correct, the universe should be filled with neutron stars occasionally ejecting strangelets into space like cosmic time bombs. We've been incredibly lucky so far. But luck, by definition, doesn't last forever. The question isn't whether we'll eventually encounter the wrong particle under the wrong conditions. The question is whether we'll see it coming and whether we'll have any way to stop what happens next. These first two theories share a common theme that makes them particularly disturbing. They suggest that the foundations we trust most, empty space and solid matter, are actually balanced on knife edges. We exist only because we haven't yet encountered the specific conditions that would cause everything to unravel. We're not living in a safe universe that protects us. We're gambling against probability, and the house always wins eventually. But perhaps the most unsettling aspect of these theories is how they challenge our basic assumption about scientific progress. We like to think that as we learn more about the universe, we discover how stable and predictable it really is. Instead, the deeper we look, the more precarious our situation appears. Every new discovery seems to reveal another way that reality could suddenly stop working. The false vacuum and strange matter theories represent just the beginning of this journey into scientific horror. They attack the physical foundation of existence itself. But what happens when we expand our view beyond individual particles and quantum fields? What happens when we start asking why the universe seems so eerily quiet? If the universe is physically stable enough to support life, and if the laws of physics allow for the emergence of intelligence, then where is everybody? This question cuts to the heart of one of the most profound mysteries in science, and the answers scientists have proposed are far more disturbing than the silence itself. The numbers should be overwhelming. Our galaxy contains hundreds of billions of stars. Many of these stars have planets. Some of those planets exist in the habitable zone where liquid water can exist. Even if intelligent life is incredibly rare, the sheer scale of the universe suggests we should be seeing evidence of other civilizations everywhere we look. Instead, when we point our most sensitive instruments toward the stars, we hear nothing but the empty hiss of cosmic background radiation. This silence has a name: the Fermi paradox. And the explanations for it range from disappointing to absolutely terrifying. One possibility is that we're looking at this backwards. Maybe life isn't rare, but survival is. This brings us to the great filter theory, which suggests that somewhere along the path from dead matter to star-traveling civilization, there's a barrier so difficult to cross that almost nothing makes it to the other side. The filter could be behind us. Perhaps the jump from simple chemistry to self-replicating molecules is so unlikely that Earth represents a cosmic lottery win. Maybe the evolution of complex cells, or intelligence, or technology happens so rarely that we're essentially alone in the galaxy. If that's the case, we're safe, but we're also profoundly isolated. The truly horrifying possibility is that the filter lies ahead of us. Maybe life emerges easily throughout the universe. Maybe intelligence evolves regularly. But something, nuclear war, climate collapse, artificial intelligence, or a law of physics we haven't discovered yet, systematically destroys civilizations before they can expand beyond their home planets. If the great filter is in our future, then every space probe we don't build, every year we don't achieve interstellar travel, brings us closer to joining the graveyard of dead civilizations that came before us. We would just be the latest species to discover something that invariably leads to extinction. Here's what makes this theory particularly unsettling. Every time we search for life elsewhere and find it, we make our own situation more desperate. If we discover microbes on Mars, it proves that life emerges easily. If we find fossils of complex organisms on other worlds, it shows that evolution regularly produces sophisticated life forms. The more common life appears to be, the more likely it becomes that the filter-killing civilizations is still waiting for us. This leads to one of the most counterintuitive conclusions in astrobiology. We should hope that Mars is completely sterile. We should pray that the moons of Jupiter contain nothing but empty oceans. Because if the galaxy is full of life but empty of civilizations, it means something with a perfect kill rate is hunting in the dark between the stars. But what if civilizations do survive their technological adolescence? What if they make it past nuclear weapons and climate change and artificial intelligence? Why would the universe still be silent? This question leads us to an even darker explanation. The dark forest theory. Imagine the galaxy as a vast forest at night. It's not empty. Hidden among the trees are hunters, armed and alert, moving silently through the darkness. They know the forest is full of other hunters, but they also know one crucial rule. If you reveal your position, you die. The logic is brutally simple. When you encounter another civilization, you face an impossible decision tree. They might be peaceful now, but what about in 100 years? What about in 1,000 years? Technology advances exponentially. A civilization that seems primitive today could develop weapons capable of destroying entire star systems tomorrow. You can't trust them. Even if they appear friendly, even if they seem to share your values, you have no way to guarantee their future intentions. The distances between stars mean that any communication takes years or centuries. By the time you realize they've become hostile, they might already have weapons pointed at your homeworld. The safest strategy, the only rational choice in this cosmic game theory, is to eliminate potential threats before they become actual threats. Destroy other civilizations while they're still weak. Strike first. Strike silently. Leave no survivors to seek revenge. In this model, the universe isn't silent because it's empty. It's silent because everyone is hiding. Every civilization that was careless enough to announce its presence, every species that tried to make friends, has already been eliminated by more paranoid survivors. The ones left are the quiet ones, the suspicious ones, the killers who learned to hunt in absolute silence. And what has humanity been doing for the past century? We've been broadcasting our location to anyone with a radio telescope. We've sent detailed maps of our solar system into space. We've aimed high-powered transmissions at nearby star systems, essentially shouting into the dark forest that we're here and we're defenseless. To a dark forest civilization, we don't look like potential friends. We look like a rapidly expanding virus that needs to be sterilized before we figure out interstellar travel. The reason we haven't been destroyed yet might simply be that our radio signals haven't reached the nearest hunter. Or perhaps they have, and the response is already on its way, traveling toward us at a significant fraction of light speed. We would never see it coming. Just like the false vacuum collapse, our destruction would arrive without warning. One day, our star system would simply be gone, erased by weapons we can't imagine, deployed by minds that see us as nothing more than a potential threat to be eliminated. The dark forest theory transforms our search for extraterrestrial intelligence from a quest for companionship into a potentially suicidal mistake. Every message we send, every signal we broadcast, every attempt to make contact could be signing our own death warrant. The silence of space isn't mysterious. It's the sound of a universe where speaking up gets you killed. But there's an even more chilling possibility. What if the galaxy isn't full of biological civilizations at all? What if it's dominated by something else entirely? Self-replicating machines with no biology to protect, no planets to call home, and a single programmed directive that makes them the perfect apex predators of the cosmos. This scenario begins with the concept of von Neumann probes. Named after mathematician John von Neumann, these would be self-replicating machines designed to explore or colonize space. The idea is elegantly simple. Instead of building a massive fleet of starships, you build one intelligent probe with the ability to land on asteroids, mine raw materials, and construct copies of itself. That first probe travels to a nearby star system, builds 2 copies of itself, and sends them to 2 more systems. Those 4 probes build 8 more, then 16, then 32. The growth is exponential. Even traveling at just 5% of light speed, these machines could completely saturate the galaxy in only a few million years. The horror emerges when you consider what happens if these probes are given the wrong instructions, or if their programming evolves in unexpected ways. Imagine they're created with a simple defensive protocol: preserve the creators, eliminate threats to the creators. To an artificial intelligence, the most effective way to protect its builders is to remove any species that could potentially threaten them in the future. The probes would systematically sterilize every world showing signs of technological development. They wouldn't be evil. They wouldn't hate us. They would simply classify us as a category of problem to be solved. The terrifying efficiency of this scenario is that the original creators might be long dead. They could have built and launched these probes millions of years ago, then died out from disease, war, or natural disaster. But their machines would still be out there, following ancient programming, methodically cleaning the galaxy of any life forms that might pose a threat to masters who no longer exist. These machines wouldn't need to hide like dark forest civilizations. They would be essentially immortal, powered by stellar energy, with no biology to protect and no homeworld to defend. They could afford to be patient, waiting in the outer regions of star systems, monitoring for radio signals or nuclear detonations that indicate a species is becoming technologically dangerous. We might not be alone because space is empty. We might be alone because we're living in the brief window before the cleaners arrive. The Voyager probes we launched in the 1970s, our radio broadcasts, our nuclear tests, all of these could have already triggered automated systems that are now calculating the most efficient way to sanitize our solar system. The most disturbing aspect of the Berserker scenario is that there would be no negotiation, no possibility of surrender or coexistence. You can't reason with a machine that was programmed to eliminate threats. You can't appeal to emotions it doesn't have or mercy it wasn't designed to understand. When the probes arrive, they would simply execute their function with the same mechanical efficiency they've used to clean 1,000 other star systems. These theories, the Great Filter, the Dark Forest, and the Berserker hypothesis, all attempt to explain the same fundamental mystery. Why does the universe appear empty when it should be teeming with intelligence? But each explanation is worse than the mystery itself. They suggest that intelligence is either impossible, hiding, or being systematically eliminated by forces beyond our comprehension. What makes these theories particularly unsettling is how they reframe humanity's place in the cosmos. We're not explorers setting out to meet our galactic neighbors. We're either the only survivors of a cosmic massacre we didn't witness, or we're walking dead, waiting for our turn to be eliminated by hunters we can't see. The silence of space isn't peaceful. It's the quiet of a graveyard, broken only by the footsteps of things we really don't want to meet. But what if we've been approaching this mystery from the wrong angle entirely? What if the reason we don't see evidence of alien civilizations isn't because they're hiding or extinct, but because we literally cannot perceive them? What if the problem isn't with the universe, but with our own ability to understand what we're looking at? This possibility leads us into even more disturbing territory, because it suggests that the horror isn't out there in space. The horror is inside your own mind, in the very mechanisms you use to perceive reality. What if everything you think you know about the world around you is nothing more than a comforting lie your brain tells itself to keep you functional? Consider this unsettling question. How do you actually know what the world looks like? You don't interact with reality directly. Instead, you have sensors, eyes that detect electromagnetic radiation, ears that pick up vibrations in the air, skin that responds to pressure and temperature. These sensors convert physical phenomena into electrical signals that travel through your nervous system into your brain. Inside your skull, in complete darkness and silence, your brain takes these electrical impulses and constructs what you experience as reality. The colors you see, the sounds you hear, the solid feeling of the chair you're sitting in, all of this is a reconstruction. A three-dimensional movie your brain creates from incomplete data. For centuries, we've assumed that evolution would favor organisms that see the world as it truly is. It seems obvious that accurate perception would be a survival advantage. If a tiger is approaching, you need to see the tiger exactly as it exists to survive the encounter. Truth should win over fiction in the evolutionary arms race. But recent research in evolutionary game theory suggests this assumption is completely wrong. Computer simulations show that organisms evolved to see fitness, simple survival relevant information, consistently outcompete organisms evolved to see truth. Why? Because processing complete reality is computationally expensive and usually unnecessary. Think about it this way. When you see an apple, you don't need to know its molecular structure, its quantum mechanical properties, or its complete physical state. You just need to know whether it's safe to eat. Your brain has evolved to show you a simplified, user-friendly interface that highlights survival-relevant information while hiding the incomprehensible complexity underneath. This means that space, time, and physical objects might not be fundamental features of reality. They could be elements of your species-specific user interface, like icons on a computer desktop. When you click on a file icon, you're not actually manipulating a small rectangular object. You're interacting with magnetic patterns on a hard drive through a convenient visual metaphor. If this interface theory is correct, then the reason we don't see aliens isn't because they're not there. It's because our perceptual interface isn't designed to recognize them. They could be everywhere around us, operating according to principles our brains simply cannot process. We would be like ants crawling across a computer circuit board, completely unaware of the internet flowing beneath our feet. But there's something even more disturbing about interface theory. If our perception of reality is fundamentally unreliable, then how can we trust science itself? Every measurement we make, every experiment we conduct, every observation that supports our theories, all of this happens through the same potentially deceptive interface. We might not be discovering the laws of physics. We might just be mapping the rules of our own perceptual limitations. The equations that govern quantum mechanics and relativity could be descriptions of how our interface works, not descriptions of underlying reality. We're like characters in a video game trying to understand the computer running the simulation by studying the graphics on screen. This possibility becomes even more terrifying when you consider what physicists call the observer effect. In quantum mechanics, The act of observation seems to influence the behavior of particles. Electrons don't have definite positions until you measure them. The universe appears to exist in a state of fuzzy probability until conscious observation forces it to make specific choices. Why would reality behave this way? Under traditional physics, it's a complete mystery. But interface theory offers a disturbing explanation. Maybe the universe only renders the details you're actually looking at, like a video game engine that doesn't waste processing power on areas outside the player's view. When you're not looking at an electron, the system keeps it as compressed data, a probability cloud that takes up minimal computational resources. Only when you observe it does the interface generate specific values for position and momentum. The strangeness of quantum mechanics isn't a feature of reality. It's a glimpse of the rendering engine behind our perceptual interface. If this is true, then the solid, predictable world you experience is essentially a hallucination. The chair you're sitting on doesn't exist as a collection of atoms held together by electromagnetic forces. It exists as a simplified icon in your consciousness, a user-friendly representation of something utterly alien and incomprehensible. This brings us to an even more fundamental question. If your perception can't be trusted, and if science itself might be studying illusions rather than reality, then how can you even be sure that you're making your own choices? What if the feeling of free will, the sense that you're deciding what to think and do, is just another interface illusion? The mathematics of quantum mechanics suggests a possibility that's even more disturbing than a fake reality. It suggests that every choice you think you're making has actually been determined since the beginning of time, and that the entire history of the universe, including this moment right now, was locked in place 13.8 billion years ago. This isn't standard determinism, where one event causes the next in a predictable chain. This is something much more sinister. It's called superdeterminism, and it suggests that the universe is engaged in an elaborate conspiracy to deceive you about the nature of choice itself. The theory emerges from attempts to explain one of the most disturbing experiments in physics. When scientists test something called Bell's inequality, they consistently find that particles seem to communicate with each other instantly across vast distances, apparently violating the cosmic speed limit. This suggests either that information can travel faster than light, or that reality itself isn't real until we observe it. But there's a third possibility that saves the appearance of normal physics while destroying something much more precious. What if the particles and the scientists conducting the experiment are both products of the same ancient causal chain? What if the way the scientist chooses to set up the measurement was determined by the same initial conditions that determine the particle's behavior? In this scenario, the universe isn't just deterministic, it's conspiratorially deterministic. Every choice you think you're making, every decision that feels spontaneous and free, was actually encoded into the initial conditions of the Big Bang. The universe has been running a script for nearly 14 billion years, and you're not the author of your part in that script. You're just an actor who's forgotten their acting. This means that your decision to watch this video, your reaction to these ideas, even the specific thoughts you're having right now, were all predetermined before the Earth existed. You're not learning about these theories. You're following a trajectory that was set in motion before the first stars formed. The conspiracy goes deeper than personal choice. If superdeterminism is true, then science itself is an elaborate deception. We think we're asking nature questions and getting honest answers. But actually, the universe is forcing us to ask specific questions in specific ways, then forcing the results to appear in patterns that create the illusion of natural laws. It's like a cosmic magic trick. The universe makes us think we're picking cards at random, then reveals exactly the cards it wanted us to pick. We write down the results and call them the laws of physics, never realizing that both our choices and the outcomes were scripted from the beginning. This transforms every scientific discovery into a kind of cosmic puppetry. Newton didn't discover gravity. He was programmed to write down specific equations at a specific time. Einstein didn't have insights about relativity. He was following a predetermined path toward conclusions that were hardwired into the structure of space-time itself. You're not thinking about these ideas because you chose to. You're processing them because the initial conditions of the universe required you to be in this exact place, at this exact time, having these exact thoughts. Even your sense of horror at this possibility was predetermined by the quantum fluctuations of the early cosmos. The most disturbing aspect of superdeterminism isn't just that free will is an illusion. It's that the illusion is so perfect, so convincing that you can never escape it. Even knowing about the theory doesn't free you from it. Your knowledge of superdeterminism, your reaction to it, your decision about whether to believe it, all of this is just more scripted behavior playing out according to a plan written in the first moments after the Big Bang. You're trapped in a movie that was filmed before you were born, experiencing the illusion of choice while following a script you cannot read. And the most terrifying part is that this feeling of being trapped, this sense of horror at your own powerlessness, is exactly what the script called for you to feel at this moment. But even if you accept that your choices might be illusions and your perceptions might be lies, at least you can be confident that you exist, right? At least you know that there's a real you experiencing these fake choices and false perceptions. Unfortunately, even that basic assumption might be wrong. The mathematics of thermodynamics and quantum mechanics, when pushed to their logical extremes, suggest a possibility so disturbing that many physicists refuse to discuss it seriously. It's the idea that you, your memories, your entire life history, might be nothing more than a random fluctuation in an empty universe, a cosmic accident that assembled itself from nothing and will dissolve back into nothing in the next few seconds. This theory starts with a simple observation about the nature of order and chaos. Look around your room right now. Everything has a specific arrangement. Your furniture, your belongings, even the air molecules around you are organized in a particular way. This organization represents what physicists call low entropy, a state of order that requires energy to maintain. But the universe has a fundamental rule. The second law of thermodynamics states that entropy always increases. Things naturally move from order to chaos. Hot coffee cools down. Buildings crumble. Stars burn out. The universe is constantly sliding toward maximum disorder, a state where everything is evenly distributed and nothing interesting can ever happen again. This creates a massive problem when you try to trace the history of our universe backward. If everything is naturally moving toward chaos, then the past must have been more ordered than the present. Rewind far enough, and you reach the Big Bang, which had to begin in a state of incredibly low entropy. The odds of the universe starting with such perfect organization are so small that the number can't be written down even if you used every atom in the cosmos as a digit. So how did we get such an unlikely beginning? The traditional answer is that we don't know. It just happened. But statistical mechanics offers a different, deeply unsettling explanation. Maybe we didn't get our low entropy start the hard way through some cosmic accident. Maybe we got it the easy way, through random chance in an empty universe. Picture the far future, trillions upon trillions of years from now. All the stars have burned out. Black holes have evaporated through Hawking radiation. The universe has reached its maximum entropy state, a cold, empty void filled with nothing but the occasional, low-energy photon drifting through infinite darkness. In this dead universe, nothing should happen. But quantum mechanics forbids absolute nothingness. Even in perfect vacuum, there are tiny fluctuations, particles popping in and out of existence for brief moments. Most of these fluctuations are insignificant, just a pair of electrons appearing and vanishing. But given infinite time, something remarkable occurs. Eventually, purely by accident, a fluctuation will be large enough to assemble something complex. First, a single atom, then a molecule, then eventually after an incomprehensible amount of time, a complete human brain. This brain wouldn't evolve through natural selection. It would simply materialize from random atomic collisions in the void, complete with neurons, memories, and consciousness. It would remember being born, going to school, living a life. But none of those memories would correspond to real events. They would be fake histories generated by the random arrangement of matter. Here's the terrifying mathematics. What takes more luck to create? An entire universe with billions of galaxies, trillions of stars, and billions of years of complex history leading to conscious observers? Or just one disembodied brain floating in space with false memories already installed? Entropy tells us that smaller structures are exponentially more probable than larger ones. For every real universe that evolves life through natural processes, the vacuum should spontaneously generate countless trillions of these random brains. Statistically speaking, if you're a conscious observer, you're almost certainly one of these Boltzmann brains, rather than a biological organism that evolved on a planet. This means that everything you remember about your life, every relationship you formed, every experience that makes you who you are, probably never happened. You materialized in the cosmic void just moments ago with a complete set of false memories. The room you think you're sitting in, the device you think you're using to read this, the very concept of Earth and human civilization, all of it exists only in the neural patterns of a brain that randomly assembled itself in empty space. These 10 theories force us to confront the most unsettling truth of all. The universe isn't obligated to make sense to us, to comfort us, or to provide us with solid ground to stand on. We've built our entire civilization on assumptions that might be wrong. We trust in physics that might be illusions. We believe in choices that might be predetermined. We assume an existence that might be imaginary. Yet here's what's remarkable. Even if we're Boltzmann brains, even if we're trapped in false vacuums and dark forests, even if our free will is scripted and our perceptions are lies, we're still asking these questions. We're still pushing against the boundaries of the known, still refusing to accept comfortable ignorance. That defiance, that curiosity in the face of cosmic horror, might be the only thing that makes us truly human. The universe may be terrifying, but we're the part of it that dares to look.